I'm presenting chapter 4. The topic is seismic vulnerability assessment of existing buildings in urban area. Uh, for this study, Muhammad Mizanur Rahman sir was helping me and supervised me. So Dhaka city is recognized as an earthquake threat susceptible city for its geological and geomorphological setup and indiscriminate and unplanned development of buildings. In current times, the collapse or tilting of a proper quantity of the construction of buildings is taking place in Dhaka city due to non-engineered constructions of the buildings. Even detailed area plan of the city did not reflect on consideration of hazard sensitive and land use planning. So development of vulnerability research in city areas can be performed for aiming to identify building risk and minimize the seismic risk. So for this study, the research question was how the level of seismic vulnerability can be assessed in the study area. So for this research question, we had two objectives. Those were to explore present scenario of the study area and to assess the seismic risk of earthquake vulnerability in the study area. The expected outcomes was to present scenario find out the present scenario of building collapse risk and vulnerability of earthquake in the study area, and it will also try to develop some policy recommendations to reduce the earthquake vulnerability by the study area perspectives. So we all know about the earthquake and what is seismic vulnerability. So we had used the visual rating method, which was developed by working group 2. And in the visual rating method was modified from visual screening method, specially designed for implementing in the build-up environment for assessment. So it is possible which structures are paka and the building height is between 2 to 6 stories. The use of the buildings is also mixed with a large variety like for residential, commercial, community facilities, industrial, mixed use and others. This is the visual rating index calculation. Here is some equations and after all the modification, the last one is the final output for the visual rating index calculation, where there was some modification. The modifications were vertical irregularity, horizontal irregularity, deterioration of concrete, and years of construction. So for the methodology, we surveyed from snowballing sampling method. This is the methodology flowchart by which we had worked. So we collect primary data and then using VR manual, we had calculated and then thematic map prepared by ranking of vulnerable buildings. So we had surveyed 37 buildings for calculation of visual rating index. For the study area, we selected Dhaka Ward No. 30, Dhaka North City Corporation area, which is situated in the middle of the Dhaka city. Here the total population is 186,639 people. So here is total building is 7,467. This area is situated near the bank of the Purigonga River, and the development of this area is with filling the riverside lowland, which is mixed and silty sand and soft soil. So here the different housing societies were developed So these also indicate rapid urbanization and development of this study area. This is the location map of the study area showing in the boundaries. By snowball sampling on basis of building age and building height, categories of the buildings were analyzed for the vulnerability assessment. Buildings were assessed through the help of the local community leaders and the volunteers of disaster risk reduction and mitigation. In the right side, we are showing the land use of the study area, where it is showing that it is 78.55% area is covering with residential buildings. This is the map showing the existing situation of buildings of the study area and the existing road network map of the study area. This is the surveyed buildings land use. Here we can see the 62% buildings were residential and 22% were mixed use, both residential and commercial purpose. We have surveyed 2-storied to 6-storied buildings. We surveyed 6-storied buildings most. Most of the buildings were 21 to 30 years older. And assessment of seismic vulnerability of the study area. For this, we can see the boundaries for visual rating method here. The calculations, and after that we get the map of visual rating index of ward nong 30 from the visual rating index calculation. Here we can see 43.24% buildings have less possibility of collapse, and almost 5.41% buildings have been identified with light damage possibility, and 10.81% has no damage possibility. Near about 10.81% buildings have the highest possibility of collapse during the earthquake. After the calculation and findings, we suggest some guidelines for retrofit, that during construction, following components should be kept in the priority, like foundation, beams, column, connection between wall and column, and some specific recommendations that need to be incorporated into the plans and policies for better management of any severe earthquake in near future are like ensure the implementation of existing laws and regulations, especially BNBC 1993 and land use plan, and train up professionals like engineers, construction workers, academicians, etc. Procedure of heavy equipment such as cranes and associated gears that can go to work following a devastating earthquake. Develop emergency search and rescue plan in respect of communication, transportation, and medical service. And there should setting up a seismological observatory network equipped with modern and sensitive earthquake monitoring facilities for continuous monitoring and prediction. And also all the important structures like hospitals, school, government buildings, and others important buildings have to be immediately made earthquake proof to minimize damage and loss of future events on a priority basis. So in conclusion, I want to say a comprehensive and well-coordinated earthquake disaster mitigation plan for the urban as well as rural areas ought to be developed without any delay and enforced on a priority basis with available resources. And for effective emergency response plan, prior integrated risk assessment of urban resources is also essential. So thank you.